In this video, we're going to be talking about how to simplify radical expressions that involve sums and differences. So this is kind of a different methodology or different train of thought than what we've been dealing with previously, where we have products and quotients of radical expressions. So here we're actually adding and subtracting them. So we're going to talk about how to deal with this sort of situation in this video and in subsequent videos. So looking at what we have here, the first thing I want you to be aware of, and I've mentioned this in previous videos, is that if I have two things being added together inside a square root, this is like a tangent. So if I have two things being added together inside a square root, this is not equal to the square root, the sum of the square roots. This is not true. Similarly, if I'm looking at a sum or a difference of square roots, and I'm starting over here, I cannot convert this back into a giant radical. It doesn't work that way over sums or differences, okay? It only works over products and quotients. So that's just an aside. I'm gonna need that space, so I'm taking that back. And okay, so we're looking at this expression here, 3 root 2x minus root 16x plus square root of 72x. How do we deal with this? Well, my first thought would be to, this root 2x, we only have 1, 2, and 1x, so we can't really simplify this guy any further. However, I have this root 16x. 16 can be broken down. It can be factored. Similarly, 72 can be broken down. So how does 16 break down? Use factor tree. We have 4 times 4, which is just 2 times 2 times 2 times 2. Okay, so now we have a cluster of 4 of these guys, but since we're working with a square root, we only want clusters of 2. Okay, now let's look at the 72. Let's do that as well. We have 72 broken down, so this is going to be 36 times 2, because 72 is even, so I just divide by 2 until I get something I know how to work with. Then I have 6 times 6, and then 6 breaks down into 2 and 3, and 2 and 3. So how many clusters of 2 do I have? I have 1 here, and I have 1 here and 1 here. So I have 3 2s, and I have 2 3s. So I have one pair here, I have a pair of these guys. I have a spare 2 right there. Okay, so now let's rewrite this expression. I can't do anything with the first one, so I have 3 times square root of 2x minus, okay, we broke down 16 into 2 squared times 2 squared. So we have 2 squared times 2 squared. And then this x just came along because we couldn't break down x any further. Okay, we only have one of them. So 72, we said, broke down into a pair of 2s and a pair of 3s and a spare 2. So we have 2 squared times 3 squared times 2 times x. Okay, so we've broken these things down. We want to use our product rule for simplifying these. So we didn't do anything with this 3 square root of 2x, so that's just going to come along for the ride. And this becomes square root of 2 squared times square root of 2 squared times square root of x plus square root of 2 squared times square root of 3 squared times square root of 2 times square root of x. I'll keep this all out here. This is all scratch work. Okay, so basically all I did in each case here, I just turned this into a product of square roots, just using product rules before. Okay, so first thing I want to do, I'll just carry this along for now. I have a square root of 2 squared, so that cancels out. That just gives me a 2. I'm literally just going to do this one step at a time here. So 2 squared square rooted, that's just 2. The negative just gets carried along, like this one. Then we have square root of x here. Then we have, okay, so what else do we have? We have square root of 2 squared. That's going to give me 2. And we have 3 squared square rooted. That's just 3. Then I have a square root of 2 times the square root of x, because those can't be broken down any further. So simplifying as possible, we have 3 times the square root of 2x minus 4 square root of x plus 6 square root of 2 times square root of x. Okay, so At this point, you could be like, okay, this is pretty much simplified, but I think we could go one step further here. Notice I have a square root of x and a square root of x in each of these terms. I want to be able to factor out a square root of x wherever possible, so I can simplify this further. Duplicate writing is a bad thing when it comes to simplification. So here I have a square root of 2x. I'm going to separate that out into two things as well. So I have square root of 2 times the square root of x. I just broke that up using the product rule. So I just carry everything else along. Nothing unusual here. Copy, paste. Okay, now notice I have a square root of x in every single one of these terms. I have a minus and a plus. Okay, so I want to factor out this guy. How do I do that? Same way you normally would with anything else. So it's going to be the square root of x times the quantity 3 root 2 minus 4 plus 6 square root 2, and that's it. Because we pulled in a square root of x out of every single term here. All right, so at this point, I would say that this is a pretty good factorization. If you wanted to factor out this root 2 as well, you could, but you don't have one in all three terms, so I would just leave it as is. Or, better yet, you can say, hey, look, I have 3 root 2's and I have 6 root 2's, so how many root 2's do I have in general? The answer would be 9, so I'm basically going to combine like terms here. So I have 9 square root of 2, because I just combined this and this. That's all I did. I have 3 root 2's and I have 6 root 2's, so how many do I have in total? 9. That 4 didn't combine with anything because it doesn't have a root 2 attached to it. So at this point, this is all that we have. This is completely factorized and all the like terms have been combined. So at this point, we are done with this example. And yes, I know this was very complicated, very drawn out, but here were the main ideas. We took the numbers inside the radicals, we factor treed them, we broke up the radicals so that we could cancel out as many squareds as possible, and then we basically combined like terms and simplified as much as possible as well, while factoring out a root x. That wasn't necessarily required, but it was helpful. Okay, so if this video was helpful, please give us a like and subscribe if you haven't done so already, and I'll see you in the next one.